Let's talk about the mole, molar mass, and mole calculations. In Unit 1, we introduced you to the mole, and we told you that that is a number, sort of like a dozen means 12, a mole means 6.02 times 10 to the 23rd. Now we're going to show how we can use it to do some calculations, and we'll briefly explain why we use it in chemistry. So what is the mole? We already defined it as 6.02 times 10 to the 23rd, and that is just a number. So let's start by looking at how big this number is. In scientific notation, we see that the decimal point is right after the 6. So we're going to start with this number here, right after the 6, and we're going to go back 23 spaces from that decimal. So here we start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. And here's an example of how to say it in a different way. So I can say a mole of zinc contains 6.02 times 10 to the 23rd atoms of zinc. I can say a mole of zinc chloride contains 6.02 times 10 to the 23rd formula units of zinc chloride. A mole of carbon dioxide contains 6.02 times 10 to the 23rd molecules of carbon dioxide. A mole of silver ions contains 6.02 times 10 to the 23rd ions of silver. And of course, a mole of eggs contains 6.02 times 10 to the 23rd eggs. And now we can talk about how I know if I'm talking about an atom, an ion, a molecule. What thing am I talking about? In your notes, your page does not have quite as many options as you see here. I wanted to define a few of them a little bit more detail, so I've added, I believe, 2 lines. We'll start with A. A mole of a monoatomic element contains 6.02 times 10 to the 23rd, again, mole just means that number, atoms of monoatomic element. So why atoms? Well, whenever we look at monoatomic elements, they're composed of atoms, so we're going to talk about the atoms. Letter B. A mole of a diatomic element contains 6.02 times 10 to the 23rd molecules of that element. Here again, we're looking at an element, but in this case it's diatomic. There are 2 atoms bonded together, making that a diatomic element. Now those atoms are both nonmetals, so we know that we have molecules. Letter C. A mole of ions contains 6.02 times 10 to the 23rd ions of whichever ion we're talking about. And again, in this case, we're looking at ions, and so we know we're talking about the word ions. It tells us that that's what we're looking at. Letter D. A mole of a molecular compound contains 6.02 times 10 to the 23rd molecules of that molecular compound. So this was our example of a mole of carbon dioxide contains 6.02 times 10 to the 23rd molecules of carbon dioxide. How do I know it's molecular? Same rules as we've always seen. If it starts with a nonmetal, then we're looking at something that's molecular. And so that's what we follow here. And letter E. A mole of an ionic compound contains 6.02 times 10 to the 23rd formula units of that compound. Now this was a little bit unusual. We put formula units. When you have an ionic compound, and again, you know it's ionic because it starts with a metal or ammonium, but once you know you have an ionic compound, we know that we're going to be using the term formula unit. So formula unit is specific to ionic compounds. So we know something is an ion, a single ion, like we might say the sodium ion or the silver ion, we're going to use the word ion. If we know something is a molecular compound because it starts with a nonmetal, then we're going to say it is molecules. And if we see something as ionic, because it starts with a metal, we know that it's ionic, then it's going to use the term formula units. Now we're going to turn our attention to some calculations. You'll notice that we have our atomic mass we've seen before. We're now going to look at how that relates to the molar mass which is related to the number of particles present. Before we talk about the term molar mass, let's define some things that we know about atomic mass and related masses. So what we know is an atomic mass talks about atomic elements or any type of atom. When we talk about just one atom, we're going to talk about the atomic mass. We have another term, it's called ionic mass, and that is the mass of one ion, whatever that ion is. It's how much that one ion weighs in AMU. Then we have formula mass, and again that is for ionic compounds. And of course we have molecular mass, which is for molecular compounds. So these are for individual atoms, ions, ionic compounds, or formula units, and molecular compounds. That all shifts when we talk about molar mass. So molar mass is how much 1 mole of whatever substance you're talking about weighs. So if I'm talking about an atomic element, we're going to talk about a mole of atoms. How much does it weigh? And that's called the molar mass. If I look at a mole of ions, it's still called molar mass. If I look at ionic compounds, it's still called molar mass. And again, that's for 1 mole of the whole formula unit. So that's how many we have is 6.02 times 10 to the 23rd of those particles. Then we can look at molecular mass, and that is for 1 molecule. That's for a molecular compound, but the molar mass is still going to have the same name, molar mass. So what's the major difference between these? Notice that we have a lot of different names for the individual ones, and the units for those are always going to be AMU. On the other hand, when we look at molar masses, those are for a collection of those particles to include 6.02 times 10 to the 23rd of whatever it is. The two main differences that we see when we talk about atomic, ionic formula, and molecular mass versus molar mass, the first one is it doesn't matter what type of substance I have, it's all called molar mass. And the second one is that these are measured in grams rather than AMU. So AMU is something that we can't really measure in the laboratory because it's a very, very, very small number. Something like 6.02 times 10 to the negative 23rd. Not quite that number, but it's a very, very small number. On the other hand, when we look at the molar mass, we're looking at enough of those particles that we can weigh it. So these are the ones that we use in the laboratory because we can weigh it on the gram scale. And most importantly, this is in a measurable amount for us. The unit grams we can use on our kitchen scale. Now let's look at mathematically what's the difference between something like an atomic mass and a molar mass. So here we'll start with A. A mole of monoatomic element, so that means it's made up of atoms, weighs in grams the same as the atomic mass in AMU. For example, if I were to look at carbon, what is the atomic mass of carbon? And of course you would look at your periodic table and you look on the chart and you would see it says 12.0, and then we would add in AMU because we're talking about a single atom of carbon. If I have a whole collection of those and I have 6.02 times 10 to the 23rd atoms of carbon, we find that the molar mass is 12.0 grams, which of course helps to explain why Avogadro came up with this really funny number, 6.02 times 10 to the 23rd, and called it a mole. The whole point of it is that whatever the mass is on the periodic table can now be used a measurable quantity, and that will be grams. So when we talk about the molar mass, its unit will always be grams. And the units will be written as grams per mole because it is how much the mass of 1 mole of that substance is, rather than AMU, and it has become a measurable amount. So if we look at a mole of a molecular compound, we know that its mass in grams is going to be the same as the molecular mass in AMU. For example, if I said, what is the molar mass of carbon dioxide? To solve this problem, all you need to do is exactly what you did before to find the molecular mass of carbon dioxide. So let's give an example of that. To find the molecular mass of carbon dioxide, we had 1 carbon, and we multiply that by the atomic mass, which is 12.0 AMU. And then underneath that, we're going to add the 2 oxygen atoms that are present in the formula, carbon dioxide. We had those 2 oxygen atoms. Each of those weighs 16 AMU for a total of 32 AMU of oxygen. We want to know the mass of this whole molecule, carbon dioxide, and that's going to be 12 plus 32, which is 44 AMU. What do I do when I look at molar mass? In this case, you're going to say carbon. I have 1 mole of carbon atoms. Each mole of carbon atoms weighs 12.0 grams. And I'm going to add to that the 2 moles of oxygen atoms. Mole of oxygen atoms weighs 16 grams. I have 2 moles, so that's a total of 32 grams of oxygen, plus the 12 grams of carbon that we have, and we get a total of 44.0 grams of carbon dioxide. And of course, we'll see the same pattern whether I talk about an ion, a molecule, a formula unit, or an atom. In every case, whatever the mass was in AMU, it will now be the same thing, but it'll be measured in grams when I talk about a mole of that substance. And what's really nice, again, is the name of it is molar mass, so you don't even have to know whether it's an ion, an atom, an ionic compound, or a molecular compound. You just know you're talking about molar mass. The units will be grams. And now it's time for you to try it. So here's what we're going to do. We're going to classify each substance as an atom, an ion, a molecule, or a formula unit. So you're going to classify it first. Then you're going to find the name for the mass of a single particle, and those will be things like atomic mass, ionic mass, molecular mass, formula mass. And then you're going to find the mass of the single particle measured in AMU. And next you're going to give me the name of the mass of 1 mole of the substance. And finally, you'll calculate the mass of a mole of that substance in grams. Please make sure to write the correct units where necessary. So it's time to pause your video, and when you're done, turn it back on, and I'll give you the answers. So let's start with magnesium. Magnesium is a monoatomic element. The name for the mass of a single particle then is going to be atomic mass. The mass of that single particle is going to be, and we'll have to look this up on our periodic table, and it's 24.3. The units are AMU. The mass of a mole of this substance is going to be called a molar mass, and the mass of 1 mole of magnesium is going to be 24.3 grams. So let's try sodium oxide. We'll start with classifying it. We can see that this is some type of compound because it's got 2 different elements present, and we see in this case that this is an ionic compound because it starts with the metal sodium. We're going to classify that as an ionic compound. Next, we're going to name the mass of the single particle. 1 single particle is going to be called a formula unit, and that means that the mass of the single particle, the formula unit of Na2O, will be called the formula mass, and the mass of that single particle, Na2O, can be found by adding up all of the atomic masses. So we have 2 sodiums, each at 23, so that's a total of 46 AMU, plus the oxygen, which is just O, which is 16 AMU, for a total of 62 AMU. Now the name of a mole of this substance, if we had a mole of it, would be called a molar mass, and that mass will just be 62 grams per mole. And now let's look at calcium. Notice that it has a little 2 plus on the top that tells us that this is an ion. The name for the mass of a single ion is going to be an ionic mass. The mass of that single particle, in this case calcium, is 40.1. And again, we just looked that up off the periodic table. But we want to make sure that we don't just write the number, we have to write the units, and in this case it will be AMU. The name of the mass of 1 mole of that substance is the molar mass. In this case, it would be the molar mass of the calcium ion. And finally, what is the mass of 1 mole of calcium ions and that will be 40.1 grams. Okay, let's try the next one, which is the sulfate ion. So the sulfate ion, by name, is telling you it's an ion, and again, you can tell that because of the charge at the top there. The name for the mass of a single particle of sulfate ion is going to be the ionic mass. The mass of that single particle is a little bit tougher. We have to calculate it. So we have one sulfur, which weighs 32 AMU. We have 4 oxygens, which is 4 times 16, or 64 AMU. We total those up, and we find that we have 96 AMU for the mass of one sulfate ion. Next, we want to find the name of the mass of a mole of this substance, and again, that will be molar mass, because it doesn't matter what type of particle I have, it's always going to be molar mass. And finally, the last one is the mass of that mole. We saw that the total was 96 AMU for one particle of sulfate ion. That means this will be 96 grams for 1 mole of sulfate ions. And let's go on to PF3. So we start by classifying by looking at what the formula looks like. We can see that it's a compound of some sort. It does not have a charge on it, so it's not an ion, and it has more than one particle present, so we have both phosphorus and fluorine. We see that both of those are nonmetals. That makes this a molecular compound. That means the name for the mass of a single particle of PF3 will be the molecular mass. And let's go ahead and calculate the mass of that particle. We need to look at the periodic table. We see that phosphorus is 31 AMU, and we only have one of those, so a total of 31 AMU. Each atom of fluorine weighs 19 AMU. We have 3 of those for a total of 57 AMU of the fluorine. Now we add those 2 together, so 31 AMU from phosphorus, 57 AMU from fluorine, and we end up with a total of 88 AMU. Now if we look at the name of the mass of a mole of this substance of PF3, we're going to see that it will be molar mass. Again, it doesn't matter which type of substance I have. And finally, what is the molar mass of phosphorus trifluoride, PF3? And we find that that will be 88 grams. So that would be 88 grams per mole is how we would normally write the molar mass. Since molar masses are measured in the units grams over moles, so it'll be some number of grams divided by 1 mole of that substance, we can use this as a conversion factor. And here's what we're going to see. We can convert substances from grams to moles and from moles to grams. Those are the 2 major things we'll be using molar mass for. So let's look at the first one. What is the mass in grams of 3 moles of carbon? To do this problem, you're going to start with your 3 moles of carbon. That's the thing that we know. We're going to use that conversion factor of grams per mole to turn it into grams. So in this case, we have 3 moles of carbon. We know that the molar mass of carbon is 12.0 grams per mole, and so we want the moles to cancel. We put the grams on top, and our answer will be 36 grams of carbon. How about number 2? This one's a little bit different. In this case, it says how many moles of KCl are there in 78.2 grams of KCl? And for this problem, we're going to start with what we know. And in this case, that is that we have 78.2 grams of potassium chloride. So here we can see that we have grams to start with. We need to change from grams to moles. And the way to do that is to use the molar mass. So we'll need to find out what is the molar mass of potassium chloride. To do that, we need to find out the molar mass of potassium and add to it the molar mass of chloride. I'm looking quickly at our periodic table. The molar mass of potassium ion is 39.1 grams per mole, and the molar mass of the chloride ion is 35.5 grams per mole. We add those together and we get 74.6 grams per mole for the molar mass of potassium chloride. And in your calculator, you're going to put 78.2 grams divided by 74.6 grams per mole. That leaves our answer in moles, and in this case it's 1.05 moles of potassium chloride. Alrighty, it's time for you to try it. For these questions, I've provided the molar masses of the different elements.
do know that normally you would look those up on the periodic table. So please pause your video as you try these two problems, and then when you return, I'll show you the answers. All right, well, hopefully you were able to get these two. So let's start with number 1, which was, what is the mass in grams of 2 moles of silicon? We're going to start with our 2 moles, and then silicon is Si. So we'll write that here. And then we're going to go from moles. We need to convert it to grams. So we're starting with moles, so we're going to put moles on the bottom in the next fraction, and then we're going to put grams on the top. We keep the 28.1 with the grams, and we'll see that in our calculation it's going to be 2 times 28.1, which is 56.2. Notice that the units cancel. We have no moles left. The answer will be in grams. Okay, now let's look at number 2. It says, how many moles of magnesium chloride are there in 150 grams of magnesium chloride? So this one's a little bit different. I didn't give you the total molar mass. Let's go ahead and calculate that. So magnesium molar mass is 24.3 grams per mole. Chlorine is 35.5. We multiply this 35.5 by 2 because there are 2 in the formula, and that becomes 71.0 grams per mole. And we add 24.3 plus 71, and we find that we get 95.3 grams per mole for magnesium chloride. And then we're going to find the moles of this. We have 150 grams of magnesium chloride. We need the grams to go on the bottom. So our 95.3 grams will go on the bottom, moles will go on top, and that gives us 1.57 moles of magnesium chloride. How do these problems change when I use a diatomic element? Well, essentially they don't change. Basically, when you see a question that asks about molar mass and it involves a diatomic element, it generally means that you're going to use molar mass of the molecule. So if it says oxygen, you'll use O2. If it says bromine, you'll use Br2. And you'll find out what that molar mass is. The only time that we really wouldn't follow that is if we were asking about atoms instead. If it said atoms of oxygens, atoms of chlorine, atoms of bromine, that would be different. Or if you're asked about the molar mass of an ion. So it might be, what is the molar mass of the oxide ion, or using the molar mass of the oxide ion. In that case, it's just O because we have that -2 on there. We do not have a diatomic element at that point. So let's look at these two examples. The first one says, what is the mass in grams of 6.4 moles of oxygen? So we're going to start with what we know. We know that we have 6.4 moles of oxygen. And I'm going to write that as 6.4 MOlO2, and that's to remind myself that this is a diatomic element. Now if I know moles, that means on the bottom I need to have moles. And I'm going to have my grams of O2 on top. And when we look at the periodic table, we see that the molar mass of oxygen is 16.0 grams per mole. But that is, again, for the oxygen atom, not for the oxygen molecule that we're looking for in this question. So we need to change that to the correct molar mass, the molar mass for O2, which is going to be double the molar mass for the oxygen atom. And so we see that that will be 32 grams per mole, and that's what we'll use in our equation. So we now have 6.4 moles of oxygen times 32 grams per mole of oxygen. Again, all in the form of O2. And in our calculator, we're just going to put in the 6.4, and we're going to multiply that by 32, and we get 204.8 grams of oxygen, again, O2. And now let's try the other direction. So number 2, how many moles of chlorine are there in 17.75 grams of chlorine? Go ahead and pause the video while you try this, and then when you return, I'll show you the answer. So again, the question was, how many moles of chlorine are there in 17.75 grams of chlorine? So we're going to start with what we know, and we know that we have 17.75 grams of chlorine, and we're going to write that as Cl2. So we know that we need to change from grams to moles, and we know that grams is on the top here, so we're going to put grams on the bottom of the conversion factor, and we're going to need the moles on top. This is a molar mass question. Whenever we're changing between grams and moles, you're looking at some type of molar mass question. So what is the molar mass of chlorine? We look on the periodic table. We see that the atomic mass of the chlorine atom is 35.5 AMU, or it would be 35.5 moles if it were looking at the moles of the atomic form of chlorine, but we need the molecular form of chlorine, so that will be 71.0 grams per mole. So of course 71 goes on the bottom with the grams because it stays with the number of grams, and we put a 1 on the top. In your calculator, what you're going to do is you're going to take 17.75 and divide that by 71. We're going to cross out those grams, and the answer will be in moles, and the answer then is 0.25 moles of chlorine, Cl2. And I'm going to have you guys try these ones. The first one is, what is the mass in grams of 2.23 moles of potassium chloride? And the second one says, how many moles of potassium chloride are there in 895.2 grams of potassium chloride? Pause the video while you try them, and when you return, I'll show you the answers. So before we start really doing the problems, all we need to do is find that molar mass. Both of these are asking the molar mass of potassium chloride because we'll need to convert between grams and moles. So for potassium chloride, the molar mass of the potassium ion is 39.1. The molar mass of the chloride ion is 35.5. And the total molar mass then is 74.6 grams per mole for potassium chloride. And that should make it easier to solve these two problems. So let's do number 1. What is the mass in grams of 2.238 moles of potassium chloride? So the thing that we know in this case is the 2.238 moles of KCl. We put that on top. That tells us that we need the moles to be on the bottom, so moles of KCl on the bottom, and on top we need to convert it into grams of KCl using that molar mass. So on the top we're going to put grams, and the number that goes with that is 74.6. Now on your calculator, you're going to take the 2.238 moles of potassium chloride, and you're going to multiply that by 74.6. And that's going to be grams per mole, which leaves our units as grams, and the answer will be 166.9548. That's what my calculator says. I don't have to write all of those numbers. I'm just going to put 166.9 or 167 grams of potassium chloride. And again, because this is a multiple choice test, you won't have to worry about if you put 166.95 or 167. Those will both be correct. You'll see that the answer will be one of those two, but you won't be given two choices that are similar. Now let's look at number 2. How many moles of KCl, potassium chloride, are there in 895.2 grams of potassium chloride? As always, we start with what we know, and in this case we know that we have 895.2 grams of KCl. That tells us that we need to have grams on the bottom, and we know we're trying to get to moles, so we're going to put moles on top. That is the molar mass of KCl. And so we see that with the grams, we're going to put the 74.6. We'll put a 1 with the moles. That means on your calculator, you'll put 895.2 grams, divide that by 74.6 grams per mole. That leaves our answer in moles. And on the calculator, we see the number 12. Again, if you put 12 or 12.0, in this class it doesn't matter because we don't worry about the significant figures. You will have multiple choice questions. If it says 12.0, that is correct, just as correct as the 12 is. And now I'm going to have you try the last two. Now these two do have something a little bit tricky with them, so please go ahead and pause your video, read through it carefully, and then we'll come back and I'll give you the answers. Okay, so now let's look at number 1, and the question says, what is the mass in grams of 1.67 moles of iodine? Doesn't seem like there's anything tricky there. They give you the molar mass of iodine atoms as 126.9 grams per mole.
And here's where the difficulty is for many students. When I say iodine, you need to recall that that is a diatomic element, so that is I2. The molar mass that was given was for just one I, so I alone, not I2. So what you have to do in this case is make sure that you have the correct formula. So that means that we need to find the correct molar mass for the iodine molecule. And so that is I2, so it's going to be 126.9 grams per mole times 2, because there are 2 moles of iodine for every iodine, and that becomes 253.8 grams per mole of I2. So in the question it says I have 1.67 moles of iodine, and that's where we'll start. And then we're going to try to cancel that out, and if I just put 126.9, I will get an incorrect answer. I have to use the correct one, which says that 1 mole of I2 is 253.8 grams of I2. And then we go ahead and multiply that out. We have 1.67 moles of I2 times 253.8 grams of I2 per mole of I2, and we get the answer of 423.846 grams of iodine. So on a multiple choice test, what you might see for the answers for this question are 76 grams, 152 grams, 212 grams, 254 grams, and 424 grams. The first one is if you forgot to change it into I2 and then you did it upside down. The second one, again, is if you did it just upside down, but you did remember to change it to iodine, I2. The third one is if you did it correctly mathematically, but forgot to change it to iodine, I2. And the next one is actually just the molar mass of iodine. And the final one is the correct answer. And now let's look at the second question, and that says, how many moles of nitrogen are there in 280 grams of nitrogen? The molar mass of N is 14.0 grams per mole. And again, this one is slightly tricky because it is nitrogen, which is a diatomic element, so that means we need to use the molar mass of 28, not 14. And for this question, we'll start with the 280 grams of nitrogen N2. We're going to divide that by 28 grams of N2 for 1 mole of N2, and you will get an answer of 10 moles of N2. And in this case, if we were to see it as a multiple choice question, we would be given the options of 0.05 moles of N2, 0.10 moles of N2, 10 moles of N2, or 20 moles of N2. The 0.05 moles is if you used 14 grams of N and divided that by 280 grams of N2, which of course is wrong, and that would give us 0.05 moles. The 0.1 is if you use the correct number of the molar mass for N2, but again did it incorrectly by dividing the 28 divided by the 280. And the 10 moles is our correct answer, which is 280 grams of N2 divided by 28 grams of N2 times 1 mole of N2. And of course the 20 mole answer is if I used 14 instead of 28. So as you can see, the multiple choice is easy to find a whole series of different answers that could be correct if you did it wrong. So the only correct answer here is the 10 moles. So be aware that that is what will happen on the multiple choice. There are certain options that may appear to be the correct answer, but you have to read it carefully.